We're going to look at properties of rational exponents, and you'll need your 8-page book that we made in Chapter 6. Now, when we have rational exponents, they follow the exact same rules as regular exponents. So that's why we're going to be using our 8-page book from Chapter 6. I've got 3 examples up here, and notice that each of these examples has a rational exponent somewhere in it. So we're asked to simplify these expressions. When I look at my first one here, I need to get rid of these parentheses. Well, in order to do that, I have to distribute that 1/4 power throughout. So I'm going to have 3 to the 1/4. And now remember, when you have a power of a power, you multiply exponents. So I need to take 4 times 1/4. Well, when I do that, I get x to the 4/4. And we'll reduce that in a second here. And then with my y, I need to take 8 times 1/4, which would be 8/4. Now I need to go back and reduce it. The 3 to the 1/4 I can't reduce. X to the 4/4 would just be x to the first power, so we have just an x. And then y to the 8/4 would be y squared. On our next one, we've got several different properties going on here. First thing, I have this negative exponent out here, so I'm going to get rid of that by crossing the line and switching the sign. So I'm going to move the entire quantity, because this -3 goes to the entire quantity. So that whole quantity goes down to the bottom of my fraction, and then my exponent becomes positive. From there, I'm going to distribute that 3 out because I have a power of a power, so it goes to everything. So I'll have -2 to the 3rd power, and then x to the 1/2 to the 3rd. Well, I have to multiply my exponents again, so I'll have x to the 3/2. Now this -2 to the 3rd, I can go ahead and multiply that out, and I'll get a -8, and I will have x to the 3/2. The last one, I'm going to look at the regular numbers first, so 6. Well, as I look through my problem, there's only one regular number there, so it's just going to hang out. Then I'm going to look at my x's. Well, I have an x up here on top and an x on the bottom. So if we use our division rule from our 8-page book, that says I need to subtract exponents. So I'm going to take 1/4 minus a -1/2. When I do that, I end up getting x to the 3/4. So when I combine my x's together, I'm going to have x to the 3/4 power. Now I'm going to look at my y's. I've got y to the 10th over y to the 1/2. I'm going to use that division rule again that says I need to subtract my exponents. So I'm going to take the 10 minus the 1/2 and end up getting y to the 19/2. Make sure you leave that as an improper fraction and not a mixed number. We don't want 9.5 as an exponent. We want to leave it as 19/2. Okay, now we've got our 8-page book which is based off of having the same base. When we have the same roots, we can also simplify radicals, and we've done that in previous lessons. When we took the square root of 5 times the square root of 2, these are the same roots. They're both square roots. So what I would do is I would take 5 times 2 and get my 10. Well, now our 8-page book is the same bases. So here I have my x's, which are the same base. When I do that, I work with my exponents. So I would have taken 2/3 minus the 1/5. General rule of thumb is when you have the same roots, so like this one right here, we had the same roots, we manipulate the bases. So if I have the same root, that means I'm going to be doing stuff with my bases. If we have the same bases, like we did in this example here, I'm going to be manipulating my exponents. Okay, here's going to be kind of a comparison of same bases versus the same root. On the left side, I have 2 examples of the same bases, and you'll see that right here with the x and the x. So when I have x to this first power times x to the 1/2, since I have the same base, I manipulate the exponents. And with this particular property, I add exponents. So I'll end up with x to the 3/2. Then I'm going to take my 5 and my 3, since those are just regular numbers. 5 times 3 gives me 15. So I would simplify this one down to 15x to the 3/2. Now down here on the bottom one, I've got a lot of different things going on. The first thing I need to do is get rid of these parentheses. So I'm going to distribute that 1/5 to everything inside here. So I'll have r to the 1/5. And now when I do a power of a power like that, I need to multiply my exponents. So I'm going to end up with t to the 3/10. Now I can start trying to combine things. So I'm just going to start on the left side here. I have the 4. Regular number, as I look through my problem, I don't have any other regular numbers, so the 4 is just going to stay there. Now my r, I'm going to look for anything else that has an r for a base, and I have one right here. So when I have r to the 2/3 times r to the 1/5, I can go ahead and combine those, and I would do that by adding the exponents. So I need to take 2/3 plus 1/5, which need a common denominator of 15, so I get r to the 11/15. That takes care of my r values. Now this w to the -5th, I don't like that negative exponent. I need to take care of that. And remember, for negative exponents, we cross the line and switch the sign. So instead of leaving it in the top, I'm going to put it down here in the bottom of my fraction as w to the 5th. Then I still have this t to the 3/10. Well, I don't have any other t's to combine it with, so it's just going to stay as t to the 3/10. Now I can check this to see if it's simplified all the way by seeing if I have my r's only in one spot, my t is only in one spot, and my w is only in one spot, and my regular number has nothing it can be combined with or reduced with. Now over here we have the same roots. Now I know that they're the same roots because they have the same exponent here. So this is really 5 cubed roots of t times the cubed root of r. It's just written with rational exponents. So when I have this set up, same roots means I manipulate the bases. So I'm going to go ahead and take t times r and get tr. So I'll have the cubed root of tr. Now my 5 doesn't have anything to combine with, so it will just stay out front. Now I can write this back with rational exponents if I want, and I would have 5, and then I would have my tr in parentheses, and it would be back to the 1/3 power. So these two expressions are actually equivalent. And this last one, I have the same root again. Notice I have the 4th root here and the 4th root there. That means I'm going to manipulate my bases. So I'm going to go ahead and take 162 divided by 2, and that reduces down to an 81. So I really have the negative 4th root of 81. Now if you go on your cheat sheet and go to the x to the 4th column, you'll see that 81 is on there, and if you follow it over, it's 3. So the 4th root of 81 is 3. Now keep in mind we have this negative sign out in front, so our answer is actually a -3. And the reason for that is when I take the 4th root of 81, I get that 3, but this negative sign outside here is like multiplying by a -1, and -1 times 3 is -3. Alright, now when we're working with roots, we still have to simplify them, just like we did with square roots. And if you recall with our square roots, if I had like the square root of 8, I would go to my list and break that down into this perfect square of 4, and then 2, because the square root of 4 is 2, so I'd end up with 2 square roots of 2. We still have to do that even with cubed roots and 4th roots and things like that. So I need to go to that x cubed list on my little cheat sheet that I have, and I need to ask myself, is there anything in that column that I can divide 54 by? And as you're going through and trying that, 27 should be the first one that you can divide it by. When you divide it by 27, you're left with 2. So this cubed root of 54 breaks down into the cubed root of 27 times the cubed root of 2. Well, the cubed root of 27, if you follow it across on your sheet, is 3. Cubed root of 2 I can't break down any farther, so I would end up with 3 cubed roots of 2. Now do the same thing with this one, the cubed root of 375. When I go through my little cheat sheet, I see that 125 is the biggest thing I can divide into 375. When I do that, I have 125 and 3, so the cubed root of 125, cubed root of 3, break that down. The cubed root of 125 is just a plain 5. Cubed root of 3 just stays the cubed root of 3. So we still have to simplify the radicals even when they're not square roots. Another thing we have to do is we have to rationalize. Even with fourth roots and third roots and fifth roots, we're not allowed to have these radicals in the denominator. So if you recall what we did in previous lessons, the square root of 7 is in the denominator and it's a radical, so it's a problem. So what we did was we multiplied by the square root of 7 over the square root of 7, ended up with 5 square roots of 7 over the square root of 49, because the same root, I multiply my bases together, and then that simplified down into the 5 square roots of 7 over 7, because the square root of 49 is just 7. Now I'm going to write it a little differently using rational exponents. So the square root of 7 is the same thing as writing 7 to the 1/2 power. So with that, I would multiply the top and the bottom by 7 to the 1/2 power. And now if you look at what happens on the bottom, when I multiply these together, here I have the same basis, so I can go ahead and just add my exponents. Well, 1/2 plus 1/2 gives me 7 to the 1st power, which is the same thing I had right over here. Then on the top, I would have 5 times 7 to the 1/2 power, which is the exact same thing as 5 square roots of 7. The reason I'm showing you that is because it's how we are going to tackle this problem. Right now, I'm going to rewrite it using rational exponents. You'll find that most of the time you want to use rational exponents. So the fourth root of 7 is saying I have 7 to the 1/4. So now I have to ask myself, what exponent do I need to multiply by so that I get 7 to the 1st power down here? Well, you have to think about when I multiply numbers together with exponents, I add their exponents. So you have to ask yourself, 1/4 plus what will give me 1? Well, that's a 3/4. So my exponent is 3/4. So I need to multiply the top and the bottom by 3/4. When I do that on the top, I'm just going to have 2 and then 7 to the 3/4 power. On the bottom, 7 to the 1/4 times 7 to the 3/4 gives me 7 to the 1st. So I no longer have that radical in the denominator. I just have a 7.